All right, welcome to this quick fire revision session on a topic that, almost always pops up in your GCSE chemistry exam. We're going to be tackling AQA section 4.9.3, focusing on those atmospheric pollutants you absolutely have to know to nail those questions.
So, let's just jump right in. When you see smoke coming from a chimney or maybe a car's exhaust, what are you actually looking at? I'll give you a clue. It's not just harmless steam. No, there's a whole world of hidden chemistry going on in there, and getting your head around that is the key to this whole topic.
So here's how we're going to break it down. We'll look at the source of it all, then the specific pollutants that get made, what harm they actually do, and finally, we'll wrap up with the absolute must-knows for your exam. Simple. Okay, first things first. Let's find the source of the problem. To get a handle on atmospheric pollution, we've got to start with the fuels we're burning every single day.
Right, so most fuels we use, things like coal and petrol, are what we call hydrocarbons. They're basically just made of carbon and hydrogen atoms. But, and this is a huge exam tip, they're almost never perfectly pure. They often have other things mixed in, like sulfur impurities. And when we burn that fuel to get energy, that little bit of extra stuff is what causes some really big pollution problems.
So let's move on and see exactly how the simple act of burning these fuels creates this whole cocktail of specific and pretty nasty pollutants that get chucked into our atmosphere.
Okay, pay close attention here because this is a really fundamental concept. It all boils down to one thing: oxygen. If you have plenty of oxygen, you get complete combustion. That's the clean version, and it just makes carbon dioxide and water. But when there isn't enough oxygen to go around, you get incomplete combustion, and that's when the really nasty stuff starts to form.
Yeah, this lack of oxygen during incomplete combustion is precisely how carbon monoxide is made. You can almost think of it like a recipe gone wrong. The carbon atom, it wants to bond with two oxygen atoms to make harmless carbon dioxide, but it just can't find enough, so it settles for one, and that creates toxic CO instead.
And it's not just a toxic gas you have to worry about. That same incomplete combustion also spits out these tiny, solid particles of pure carbon. We see it as black soot or smoke, but in science we call them particulates.
Now this is where it gets really interesting. This particular pollutant doesn't actually come from the fuel itself. Nope, it comes from the air. Inside a hot car engine, the temperatures get so incredibly high that it literally forces the nitrogen and oxygen, which normally just hang out together in the air quite peacefully, to react with each other. This creates all sorts of different oxides of nitrogen, which we just group together and call NOx.
And this brings us right back to that point about impurities. Remember that sulfur hiding away in the fuel? Well, it doesn't just disappear. When the fuel burns, that sulfur impurity grabs some oxygen from the air and, bam, you've got the pollutant gas, sulfur dioxide.
Okay, so we now know how these four key pollutants get made. The next step, and this is where you can pick up a lot of marks in an exam, is to connect each one to the specific problems they cause, for us and for the planet.
Let's start with carbon monoxide. You might have heard it called the silent killer, and that is absolutely not an exaggeration. Its physical properties are exactly what make it so dangerous to people.
For your exam, you just need to remember these three key properties. First, it's a highly toxic gas. But what makes it so much worse is that it's also colorless and it's odorless. You can't see it, you can't smell it. And that combination makes it a massive health risk.
Now let's look at sulfur dioxide and the oxides of nitrogen. These two are kind of a double threat. First, if you breathe them in, they can cause some pretty serious respiratory problems. And second, when they get up into the atmosphere, they dissolve in the tiny water droplets in clouds and fall back down as acid rain, which can damage buildings, forests, and entire lakes.
And finally, what about those little soot particles? Well, just like the last two, they also cause two very different problems. They're tiny enough to get deep into our lungs, which can cause health issues, but they also have a planet-wide effect. When you get enough of them up in the atmosphere, they actually act like a giant sunshade, reflecting sunlight back into space. This reduces the light reaching the surface, an effect we call global dimming.
Right, let's pull all of this together into one final summary. I'm telling you, if you can get your head around this next slide and explain it, you are in a fantastic position for this part of your exam.
This table is gold. It brings everything together, showing the complete story for each pollutant. You can see exactly how it's formed and what harm it causes. Seriously, I'd pause right here. Cover up one of the columns with your hand and test yourself. If you can master this table, you've pretty much mastered this topic.
And that really is the single biggest thing to take away from all this.
It's all about cause and effect, the conditions of combustion, like how much oxygen there is, plus what's in the fuel to begin with. Those two things directly decide which pollutants get made and what kind of impact they're going to have. If you understand that link, you understand the chemistry of air pollution.
So, to make sure all of this really sticks in your brain, have a go at answering this exam-style question. Think back to what we just covered about particulates and try to explain their two main problems in your own words. Thanks for tuning in, and the very best of luck with your revision.